A firm manufactures and sells two products, X and Y. Suppose X and Y are the amounts of the respective products produced in a certain day with respective cost function given by Cx equals to 1000 minus 12x plus 3 over 100x squared. Cy equals to 1000 minus 10y plus 1 over 3000y cubed. Find the values of x and y that minimize the firm's total cost. So let us form the cost function Cxy. So we're going to add this Cx plus Cy. So 1000 minus 12x plus 3 over 100x squared plus 1000 minus 10y plus 1 over 3000y cubed. So let us simplify first. So 1000 plus 1000 is 2000 minus 12x plus 3 over 100x squared minus 10y plus 1 over 3000y cubed. So the first step, as usual, we need to find c sub x and c sub y. Let us differentiate 2000 with respect to x, which is 0. Differentiate negative 12x with respect to x is negative 12. Differentiate 3 over 100x squared with respect to x is 6 over 100x. Differentiate negative 10y plus 1 over 3000y cubed is 0. So let us simplify first. Negative 12 plus divide with 2 is 3 over 50x. So let us find for c sub y. So differentiate 2000 minus 12x plus 3 over 100x squared with respect to y is 0. So differentiate negative 10y with respect to y is negative 10. Differentiate 1 over 3000y cubed with respect to y is plus with 3 over 3000y squared. So if we simplify, we're going to get negative 10 plus 1 over 1000y squared. So let's equal our c sub x and c sub y with 0. So negative 12 plus 3 over 50x is equals to 0, and x equals to 12 times with 50 divide with 3. So we're going to get 200. So x is 200. Y c sub y, negative 10 plus 1 over 1000 y squared, and we equal it with 0. So our y squared equals to 10 times with 1000, which is y equals to 10,000. Sorry, y squared equals to 10,000. If we square root both sides, we're going to get y equals to plus minus 10,000, and we're going to get y equals to plus minus 100. But since y is the number of units produced, so we only take the positive value. So y equals to 100. So we have a critical points here. which is 200, 100. So what we're going to do with this critical point is we're going to substitute into the d-test, but before that we need to find the c sub xx, which is differentiate negative 12 plus 3 over 50x is 3 over 50. C sub yy, differentiate negative 10 plus 1000 y squared is 1 over 500y, because if we differentiate y squared here, we're going to get 2y. So 2 divided with 1000 is 500. So that's why we get 1 over 500y there. So C sub xy. Let us differentiate with respect to y here. So there's no y term, so it's 0. Let us substitute into the d-test, or the second order partial derivative, which is c sub xx times c sub yy minus the square of c sub xy. So if we substitute 3 over 50 times with 1 over 500y minus 0 square. So 0 square is 0. So now what we're going to do is we're going to substitute our point now. So the point just now is 200, 100, 200, 100, and we're going to substitute into our d. So 3 over 50 times 1 over 500 times with y 100. So what we're going to get here is 3 over 250, which is greater than 0. And we need to check our c sub xx. Is it c sub xx is positive? Yes, 3 over 50 is positive. So we know that our point is a minimum point. And we can make a conclusion here that 200, what is x and y just now? X and y are the amounts of the products produced, okay? So 200 units of product X and 100 units of product Y minimize the cost. What else the question asks? That's all. Find the value of X and Y that minimize the firm's total cost. So that's it.